Welcome everyone to this week's OMR Architecture Meeting. This week we have two topics to discuss. May not be a very long meeting, but still we have two things that we can spend some time on today. The first is an update from Nazim on some work that we had talked about late last year on providing port library initialization for components that are using JitBuilder, and he had done some work with that in the past, and this will be a sort of an example of how to do that initialization. So I'm going to turn it over to Nazim to talk about a pull request that he opened recently in OMR, and have us take us through that. Nazim?
Thanks, Jared. I'm just going to share my screen. Are you able to see it?
Yes.
Okay. Hello, everyone. So today I wanted to talk about the pull request, proposing the kind of solution we discussed previously. So this has been a topic that was discussed way back over 2 years ago, and we never implemented something as a pull request to have it out there and have some discussions about it, mainly because it kind of got entangled with initialization of other components. But the focus here is to be able to have the port library available in JitBuilder and Test Compiler builds, so that we can utilize more of the port library in the OMR compiler. So as it stands, the OMR port library is already built as a compiler dependency that was done a while ago. However, the work to actually make use of the port library was halted. So recently, within the last year, a few changes have happened where we have the compiler and with a member OMR port library, which is where we can access the OMR port library throughout the compilation, and it defaults to null unless the initialization of the compiler and class happens with the initialized port library. So at this time, the only use of the port library in the OMR compiler is for CPU feature detection, but we still need a fallback mechanism because we don't have the port library in all use cases. But however, with JitBuilder and Test Compiler ensuring that there is always an initialized port library, we can get rid of these fallback mechanisms and be able to utilize the port library more readily. And right now, OpenJ9 is the only OMR compiler user that is actually setting this field and using the CPU detection capabilities in the OMR compiler. With my pull request 5798, all it does is it affects the JitBuilder and Test Compiler initialization with shutdown, where we initialize the thread library, which is required for the port library, and then use that, and then pass that port library to the compiler and the constructor. And for shutdown, so it shuts down the port library and the thread library. So the way it affects JitBuilder users is that in addition to initialize JIT and initialize JIT with options, which will, the initialization that you saw here is basically going to be part of initialize JIT and initialize JIT with options. However, users of JitBuilder should be able to initialize their own port library, and they will be able to then basically initialize the JitBuilder multiple times per process, because right now one of the constraints is that the thread library can be initialized once per process, and if a user is using JitBuilder, like initializing JitBuilder more than once, then they will have to be the ones handling their own port library initialization and shutdown. So this also will introduce initialize JIT with portlib and initialize JIT with options and portlib. So that will provide a way for JitBuilder users to provide a pointer to their port library. I just wanted to hear of any opinions about this approach. So this is still a work in progress, but I just wanted to hear any opinions about the approach being taken here. But it will not be affecting existing JitBuilder users because if they're still using initialize JIT and initialize JIT options, they don't have to handle the port library initialization anymore. So so that was the end of my slides over here, and so I just wanted to begin a discussions around this, and if you have any questions, try to answer them now. Thank you.
Thanks, Nazim. I think I know the answer to this, but can you provide the use case for initializing JitBuilder multiple times per process?
Well, one of the use cases actually in OMR itself, we have the JitBuilder test cases where we have so we subclass testing test of Google test class, and then we have like each test case in that class initialize the JitBuilder every time a test case is run. So over there, we cannot do multiple thread library initialization because it's the same process. So which is why they will have to, like in such a case, we'll have to handle they'll have to handle the initialization of the port library themselves.
Yeah. Okay. Thank you. I guess another thing that we can enter into the official record here is perhaps a question that Mark had asked on in the PR itself as to what the measured increase in size in shared object size was for including the port library in a
right. Yeah, I should have included that in my slides. So it will be about a 4% increase in file size of the users of JitBuilder. So then that is based off from, I mean, that's the number I've observed by looking at the JitBuilder sample. So it can vary. So we'll see.
So is the primary motivation here to make the implementation simpler so we don't have to continually check to see if there is a port lib that's been initialized, or is it
yeah, that's one of the goals.
Okay, but is it the most important one, or is it the, I guess so, because that I have to weigh that against the 4% increase in size for a, I guess an internal detail for JitBuilder. I guess the other advantage here is the fact that if if you're using other components of OMR with JitBuilder, you would be able to provide a port library. I guess I'm just wondering if the initialization of the port library needs to be or could be a CMake kind of config option, which would allow you to, basically make that 4% size trade-off. But the implementation retains its complexity. So how can you characterize how much of an onus that is for us to be checking the portlib in the code base?
Well, the portlib is required for any kind of use of the port library. So because, well, basically the check, the way it is done is we check for whether the port library member of the compiler and class has been set or not. And if it's not, then we have to use a fallback mechanism and basically have to have a duplicate implementation of what already exists in the port library.
Okay, but so we're only using that for CPU the port library for CPU detection right now?
Yes, yes. But there is more use cases that we can exploit more of the port library once there is more. Once we have every build configuration of the OMR compiler actually making this available. So so right now the CPU detection feature is the start, but there is a lot more opportunity for using that.
So I think what Mark was asking about was if you did, and Mark, correct me if I'm misunderstanding your question as well, every place where you would go about using the port library within the OMR compiler, you would need to check first if the port library is available, and if so, then do that call. But presumably that would have to have some either like an empty implementation if it's not supported, and so that the builds don't break, or they have to be if-def'd out in some way. Is that what you were asking, Mark?
So, sort of. I guess. So what's being proposed here is that we basically always initialize a port library for the JitBuilder library, which carries that 4% size increase, and the advantage that a user gets is, at this point at least, a fairly minimal one from a user's perspective, right? Like basically we're asking them to bear a 4% size increase for no value that they're aware of, unless there's some like the CPU detection feature is much better in the port library than what they're currently getting with OMR, or would get, I guess, if we removed it. I guess I'm just worried about forcing that decision on stakeholders without any sort of way of undoing it.
So the long-term benefit is that we can remove the fallback mechanisms in place, and we can use the port library more often and remove a lot of the implementation, the duplicate implementation that we have to have in OMR. And that itself will result in a reduction in the size. Okay,
so you're expecting a 4%, less than a 4%. I guess I'm not sure I buy that.
Well, yeah.
Because the only duplicate code right now is the CPU detection code, right?
Yeah, it's unlikely to reach 4% reduction, but there will be a little bit.
All right, so I guess an alternative trade-off that we could force on people would be, I'm just fleshing out ideas here, not necessarily saying this is what I think we should do necessarily, but we could also make port library a configuration level option, where the backup plan for not having a port library is you get some dumb default for whatever code would otherwise use the port library for something, right? So in the case of CPU detection, it would be we default to the oldest processor we know anything about on that, on the whatever the platform is.
Yeah, that could be done. And I guess if it's configuration level, then we can also if-def out the fallback mechanism, and if we're building with the port library. So yeah, that's a possible solution.
Well, I mean, I'm a fan of the cleanup and moving, like not having duplicate code in the compiler and in the port library to do things like CPU detection. I don't think we should maintain multiple copies of that code, but I am cognizant that some people may not care, but they might care about a 4% size increase. Just because size has been mentioned before, like the size of the JitBuilder library has been mentioned as a concern point for some people in the past. So I'm just trying to recognize that concern and not arbitrarily grow it, because from a user standpoint, whether I'm using CPU detection that's in the compiler or CPU detection that's in the port library is of no value, no external value, right? That's just an implementation detail.
So all uses of the port library in the OMR compiler would then, I'm just riffing on that idea, would be if-def, if the port library is enabled. And the other side of that if-def would be a very dumb default implementation of whatever that feature happened to be. So we could still get rid of all the CPU identification code
right
on the dumb side, and we would just return the most basic, simple processor that. I mean, that's just the example for that. But
yeah. And I'd be okay actually with the default being that you get the port library, because there would be a fallback plan for if you really cared about that size increase, you could undo it. And then I guess the operational question then becomes, is for the future things that we might consider leveraging from the port library, is it going to be more painful for us to be able to accommodate those things not being there? Is it going to be more painful for us to accommodate the potential lack of a port library? Is that maintenance cost going to become prohibitive? And I guess, we could always undo this decision if we want in future, if it starts becoming too painful. So I think this would be a better starting point, maybe. I don't know, how does that grab people?
It seems like a sort of a more staged approach to enabling this. So you can have it built in by default, but have an option to turn it to disable it. And for the known uses of this right now, we would provide a simple fallback path if it's built out. And I guess we could add a testing mode as well, where we can build with and without the port library so that both paths are being exercised. But then things get a little bit more complicated if we go forward. Like if we have to start thinking about other places that we want to use this, like there's other features, like what other features of the port library do you want to use? I know that, things like like getting the process PID, for example, is one thing. There might be some memory allocation functions that that could be used through the port library. File IO as well, I suppose. But I think taking the path that you suggested to start with seems like a reasonable place to start to me.
It's practical to me to go ahead.
I agree. So I will be updating the pull request and have like a build configuration that is going to allow both the port library and no port library kind of scenario. So yeah, in the future we can compare. I mean, we can assess it again whether we can completely remove the need to have these two mechanisms. But I think as a starting point, this is a good solution.
Okay, and thinking about our downstream partners, so for something like OpenJ9, which introduces its own port library, it would have to enable this build option when it's building or as it's consuming OMR in order for those paths to...
So the default would be, with the port library being present. So it's the option to not build without,
right.
Not build with port libraries for people who care about the size increase.
Right. I'm just thinking through that side of the equation that nothing would need to happen for OpenJ9 for it to consume the code that is going to use the port library. That's what I was kind of getting at. Okay.
So I apologize for not having taken a look at the pull request before this discussion. So forgive me for asking such a simple question, but is the port library initialization code actually in the OMR compiler component, or is it in the JitBuilder and Test Compiler components?
It's in the JitBuilder and Test Compiler components.
Okay, that's what I thought. So okay, so what's the compiler component supposed to do when it's being consumed not from the test compiler or the JitBuilder?
I guess the OMR port library member in compiler env is going to be null, and so any place in the OMR compiler that is using the port library is going to perform that check to see whether it's available. So that's the current implementation right now.
I see. Okay, and so that's the one that OpenJ9 will be using anyway.
Yeah, they're currently actually using it right now.
Okay. Okay, so the only compiler projects that are going to be doing this port library thing are the JitBuilder library and the test compiler.
Yeah.
Then.
Yep.
Okay. And since JitBuilder isn't currently being built into OpenJ9, it's not an issue for that project yet.
Okay. Sounds like we have some consensus on the path forward with that PR, Nazim. Other comments from anyone? Questions on this approach? Other ideas? Concerns?
Well, I think that last thing basically cements that we need to be able to support the existence of a port library or not. So, right, because another project could consume the OMR compiler directly, and then they might not want to provide a port library.
Mm-hmm.
Like I could imagine Ravi or the sort of restricted compiler, OMR compiler that Dibyenu built. I could imagine that thing not wanting to include a port library. So that, I think that further supports the approach that we're talking about here.
Right. Okay. If that's all for the discussion on this one, I think we can move on to the next topic. So thank you, Nazim. If anybody has any further thoughts or comments they want to make, by all means, please review Nazim's PR and make your points there. Okay, share that again. Okay, so the next topic that was proposed was to discuss the state of the options rework. So this was a request that came from Philip. I guess maybe one question to ask Philip to get this discussion going is if there's a motivation for asking that, or what is your motivation for asking that? Is that just to move things along, or do you have a need for that kind of rework to happen in order to simplify or make something else better?
Yeah, so the context I was working under is in OpenJ9, we have a mechanism called the JIT dump, in which we can intercept signals from the JVM, for example, crashes or illegal instructions or segmentation faults or even compilation failures. And then we try to recompile the method in question, whether it's recompiling a compilation or an existing JIT compiled method. We trigger another compilation of that. In the event that we crash in the actual JIT compiler, we will attempt to re-trigger the original compilation. And before we do that, we would like to copy the options, the entire set of options that were used for the original compilation, to ensure that we can reproduce the original failure with tracing. So this boils down to being able to copy and construct the J9 or the OMR options object. But right now it contains a whole bunch of other metadata about logs and other weird counters and things like that. It's not just a set of bits that represent the actual options. So it's impossible today to copy construct that object. So that's kind of the motivation why I was trying to get an update, because I think part of the original work or design was that it's just the new options are literally just going to be a set of bits which we can copy around.
Right. Okay. So for those that aren't aware of sort of the history behind the JIT options in OMR, so we've been the way that things are implemented right now. OMR and its downstream projects are obviously separate, but when it comes time for the JIT to process command line options, for the compiler to process command line options, it not only needs to draw on options that are available from OMR, but downstream projects such as OpenJ9 can introduce their own options that need to be processed as well. And unfortunately, when OMR was created and separated from the J9 compiler in the first place, that separation wasn't done particularly cleanly. There were a lot of rough edges on the implementation that was there, and and some of those edges were actually left from previous attempts at doing option specialization for different compiler front ends that is using this framework. So unfortunately, some of those warts are still in the code, and we don't really have a clean solution for it. So one of the things that we started to work on was a much cleaner design for the way, for a means of handling and processing JIT compiler options that would work, that would integrate better with downstream projects that want to consume this framework. And we thought about a few different ways of doing it, and the way that we thought would work particularly best was really just to put together a single table that would be built at compile time. And the way that this options table would be constructed would be via some metadata in the build that would be, let's say you would describe your options via some JSON format, and all the downstream projects could describe their options in that same format as well. And as part of the build, there would be a tool that would go and grab the piece from OMR and the piece from and all the pieces from the downstream projects and stitch them all together into a single table. And that's the thing that the build would use. So you get a very clean, consistent implementation of it that you can work with. Actually, it was Nazim that spent a bit of time prototyping this, and we actually do have a prototype open there in 3675 that does work. But there were some challenges with some of the dependency. There were some concerns around some of the dependencies that that this kind of an approach would have. So OMR, for example, already has a dependency on the Python. Sorry, excuse me. JitBuilder already has a dependency on Python for some of the interfaces that it constructs at build time. But other downstream projects don't currently have a dependency on Python. So there was the one challenge about enabling this sort of an approach would require all downstream projects to now have a Python 3 dependency in their CI pipelines. So this has been discussed in the past. There are issues open where we have talked about this sort of thing. But in the end, though, I don't think that we've taken sort of the next step to push this work forward and get all the downstream dependencies resolved and get sort of an agreement on a path forward in those particular projects. In the meantime, there may be some other approaches for processing options that need to be considered. Some other ideas have perhaps come up. So that kind of thing is, should this effort get rebooted, that kind of an effort, or so those other ideas, I think, should get some consideration as part of an overall design here. The other thing about this sort of an approach, though, the way that we took with using JSON to construct tables at build time from downstream projects and OMR is applicable to more than just the options. It is useful for synthesizing tables of data that, not code, but data that the compiler would consume. So for example, things like the tree evaluator tables from all the opcodes, the value propagation table, the simplifier table. There's like a GPU code generator table. All these different sorts of structures could be synthesized this way as well. So the general technique of using JSON and Python to construct these things goes beyond just options. So, but I mean, you're asking specifically about options. So I think the short answer is that the work has unfortunately stalled, but I think that it would require maybe a refreshed view on what it is that this is trying to achieve and how the best way of fitting options into these downstream projects is going to work. So that's where things are at the moment. Now, one thing I will say is that perhaps some of the things that you're concerned about can actually be done independently of that. So for example, you're concerned about there being some other metadata being stuck into the options object that perhaps that you had to deal with when you were doing the serialization of that option structure. I know that when Nazim was going through it, he did discover that there were lots of things in there that perhaps didn't belong in the options object at all, that should live in a perhaps another class, perhaps even like an extensible class that is meant for that kind of extension. So perhaps there are things that we can do to the options object as it exists today to remove some of the things that are causing you problems, independent of coming up with a unified structure for representing options. So I'll just pause there for a sec to double check I wasn't on mute. Good. Any thoughts on that?
I certainly agree. It sounds like, in order to get Philip moving forward, it sounds like a rework of the options is a lot more than what he needs. And maybe it would be better to stage that work, and that might even simplify some of the options rework going forward.
Yeah. Yeah, there's the separation of, like, one of the things I believe, and I keep talking in place of Nazim, but one of the things that I think Nazim did was sort of separate the notion of these are the actual options that you would specify on a command line or somehow inject into the JIT versus the sort of the other state that is maintained in the options object. So I think that we could potentially, even just starting with what we have, separate the state from the processing of the options themselves. So the mechanics of parsing the command line and figuring out the order of one thing or another, or that kind of thing. So there's lots of opportunity in that options object for moving code down to OpenJ9 or even back up into OMR. More so in the downward direction, I think. And perhaps once we have something like that, it may be more apparent and a lot easier to have conversations about the proper way of restructuring the actual processing of the command line options, and perhaps unifying it with other frameworks going forward. Do you think that would be enough to unblock you, Philip? Or, I mean, I don't know if you're blocked right now. I know you're inconvenienced. I don't know about blocked, but would that be enough to help you move forward at a faster rate if the metadata was separated from the options objects?
Yeah, I mean, yes, the short answer is yes. I mean, for me, it's enough to even just mem copy the underscore options bit vector inside of the options object, but I would have preferred just to copy construct. There's other problems, for example, like the options are mutable, which is something that I guess can't wrap my head around whether we should be allowing that or not. Because there are places in the compiler where we enable and disable or flip options on and off based on some other decisions.
Yep. And there's also places where we have an enable and a disable as independent flags too.
Right.
So
that's one of the issues that I tried solving with that prototype. So yeah, it's been a while, so I'll have to refresh on my memory again. So about what I have done for that. But yeah, that's certainly one of the things that I was trying to address in that prototype.
One of the suggestions, I think, if there's concerns introducing Python dependencies, just looking at the PR, seems about 300 lines worth of Python code. I know we have tools written in C, which we compile as part of the build process, and then use like some of the DDR generation. Just a thought, I guess we could, instead of Python, just use C or C++.
Yeah, I don't remember all the options, pun intended, that Nazim, you investigated when you did the work. I think you were looking for a JSON library for C++ at one point, and maybe had some issues with that, but.
So I haven't, from what I remember, I haven't spent much time converting this to C or C++ because we decided that we're gonna go through with installing the dependencies of in the machines where the script will have to be run. Yeah, so basically it took a while to, I guess, make progress in that area, and I think that's where we're at.
Oh yeah, and sorry, it's coming back to me a little bit now. The other thing was that in OMR, which includes JitBuilder, JitBuilder already introduced a dependency on Python. So anywhere you would use OMR, anywhere you would use JitBuilder, you would have Python already there. So from an infrastructure perspective, all of the machines that were building OMR on every architecture had a Python 3 installed. The challenge was all the downstream projects, and using J9 as an example, all the OpenJ9 build machines needed to have it. All the internal OpenJ9 build, all the IBM internal OpenJ9 machines needed to have Python installed, and all the adopt OpenJDK machines needed to have Python 3 installed. I think Python 3 is a dependency. We had that dependency on adopt OpenJDK, and to some extent with OpenJ9 and the internal machines. I was just checking yesterday with Joe and what the status of some of those things was, and it looks like we may be we may not have everything installed properly on AIX, and there may not be everything installed properly on Windows, and perhaps a few other variations as well. So I think the whole Python dependency thing is a separate. We can almost separate that from this kind of design, because, like I said, there are other uses of Python that could be explored, and I don't necessarily want to tie it to one particular design. There are yeah, sorry, I lost my train of thought there. So
yeah, I remember looking once for a good JSON open source library that was written in C or C++, and I couldn't find anything that was written in there were good libraries, but they tended to use more modern C++ that wouldn't have worked as well for us. It would have had the same, it would have brought in the same kind of problems, in that you need 2 build chains to be able to support doing the build, which wouldn't have made sense either.
Yeah, we wanted to use fairly common tools and technologies in order to build this. And JSON and Python are actually quite common in CI/CD pipelines these days.
Yeah.
So it's not. I mean, it's not real. It's not an unreasonable ask to suggest Python being part of that. So it's just a matter of perhaps highlighting the benefits of this approach and the advantages that we would get from it, or the disadvantages of not doing it, to satisfy other projects in that.
Yeah, it wouldn't. I don't think it would be an unusual decision for us. I mean, LLVM has a dependency on Python. GDB has a dependency on Python. Those are pretty fundamental tools as well.
Yeah.
I actually think there's probably a meta problem here about how we manage dependencies across OMR, OpenJ9, and Adopt OpenJDK that is kind of part of the root of this problem, but that's a larger discussion point than this one, so I'll just park that thought.
Okay.
So where does that get us?
Yeah. Well,
where did we end up there?
Well, okay. Well, I mean, I think we understand maybe a little bit better. We understand what Philip is trying to achieve, and perhaps not going with an entire options rework is a possibility. And in fact, if OMR could make changes without impacting downstream projects right away, then that's perhaps a path that we can start to go down. Independently of that, like I said, I'd probably want to separate the decision about making a dependency on the Python 3 from this. Certainly use options as an example, but I would also draw in some of the other tables that we've wanted to synthesize at compile time during the build step as well as motivating that. It'll open up our options for other things as well. So yes, I'll separate that. So in terms of next steps, I don't know. I mean, Philip, I mean, I guess you're free to make some changes to options as you think you need in order to do that separation. Nazim, I don't know if there's anything that you have already done from the other PR that is reusable for that effort.
I'm not sure. I'll have to again look into what I've done and see.
Yeah. I don't, to be honest with you, I don't think so, because I know you did a fairly fundamental rework of a lot of those data structures. So I don't know if that's possible or not. The other thing about touching this kind of code is you have to be super careful about the effects of it. I remember as Nazim was debugging his work, that there were instances where what he was changing for his new framework, it was getting a different result than what the current implementation had. And he had to get creative in some cases to debug these sorts of differences. And in many cases, it wasn't obvious at all. And I think part of this also goes down to what Philip was saying about the lack of immutability of some of these options, in that there are places that can just simply turn that option off and then flip it back on again, and you have no idea that something like that has happened under your feet. And I think some of the problems that Nazim had were related to that kind of behavior happening. So something
I did set up some macros where basically for any option queries, it goes through a macro that queries both the old implementation and the new implementation, and then compares the result. That's not something done by default. It was something like options debug configuration option would build something like that. So yeah, that's one way this was addressed when we had that issue. But yeah, there were a lot of unexplained results that I observed there. But I tried to trace it back and make sure that the new options get updated along with the older one. And yeah, so that mechanism kind of helped me identify the options that get flipped around in different places.
Okay, so I mean, at the very least, I'll probably create a separate issue to talk about the Python dependency and to move that forward. Okay,
I can take a look at
sure.
trying to pull some of the stuff out of the options object that doesn't really belong there.
Yeah.
Actually, quite an interesting tour to go through OMR options.hpp and see some of the stuff that's in there. I hadn't actually realized that there was a way of creating a custom opt strategy, which I learned from perusing OMR options.hpp. Somewhat dubious that it works, but anyway, or still works.
Does it?
No idea.
The code is there. Okay.
The code is there.
Okay. Is there any more discussion people want to have on this particular topic? Okay. So if there is anything you want to bring up, there is that pull request that that Nazim has had there for, I guess it's going on 2 years now. So by all means, feel free to add some comments there if you like. But I think that this is going to be moving forward, but just given the priority of that and other things, it's just going to be moving at a little bit of a slower rate than other things. Okay, that was the last topic we had on the agenda for this week. So we'll talk again in 2 weeks. I've already created the proposed agenda for that. So if you have any topics, by all means, please add them there. I've already propagated the linkage one from that we deferred from this week to that one. So you can pick that discussion up then with Jan. Okay, that's it. Thanks everyone for attending, and we'll talk again in 2 weeks. Bye.